Introduction of engineering economics, we will see about equal payment series, sinking fund factor, equal payment series, payment present worth factor, and equal payment series, capital recovery factor. So I'm going to use the textbook Panir Selvam R Engineering Economics, which is prescribed in the syllabus. So we will move on to the topic. So first we will see about equal payment series, sinking fund factor. So equal payment series is also called as uniform series, right? So before understanding the equal payment series sinking fund, first you have to understand the equal series compound amount factor. So let's assume that the amount is almost, the amount is having an equal, and say the deposited, it is deposited in savings account, okay, or else it is placed in some other area where we have some kind of an interest at a certain period of year, or else you can say that each year, okay. So you just take this figure itself as an example now. Okay, so if the money earns interest at a rate of I, okay, so at the rate of I, and the compound which is compounded annually, and how much money will we have accumulated, after a certain period of a time, that is your N. Okay, so already we are knowing the future and present some the ratio, right? So the ratio of future and present will be, that is F by P is equal to 1 by I into power N, right? I hope that you are all well aware of that formula. Okay, so now to answer the question that if the money earns the rate at the interest rate at for I rate, okay, so and with the which is computed annually, and how much money will be having accumulated after n years, so you just take that f1, that is a future amount 1 is equal to a. So here the a is the equal amount of money. Okay, so 1 plus I power n minus 1. So n minus 1 is this over this area. So the area, so say for an example, so after this 4, just having some 4, and then having the year of n minus 2, n minus 1, like this, it is getting decreased. Okay, so by having considering like that, then we are having that a into 1 plus 1 power n minus 1. So that is that we know that after n years, the first year deposited will have increased in the value of f1 is equal to a 1 plus I power n minus 1, right? So likewise, we have to find the second year deposited. So that will be f2 as is equal to a into 1 plus I n minus n, to the power of n minus 2, right? So likewise, we have to find the total amount accumulated. Okay, so with that, we will we can deduce it into the ratio of f by a is equal to 1 plus I power n minus 1 divided by I. So this part is called as the equivalent series compound amount factor, or else uniform series compound amount factor. Because again, this part we will be using in the sinking fund factor also. That's the reason why I'm explaining this. Okay, so however, the numerical value of this factor can be obtained you know directly, uh, or else by using the mentioned this formula, or else you can have a set of compound interest tables which economics still used to have it. Okay, so those tables you can get it, like compound interest factor, annual compounding. Okay, so there are some kind of a charts. If you want, then you can also use it, but you and also these theories, either by using this formula or else the chart, the tables will help you to solve these kind of uniform series problems. Okay, so you just note down this formula. Okay, so I hope you are understanding that how we have arrived. Okay, so now moving on to the uniform series a sinking fund, or else which is so called equal payment series sinking fund. Okay, uh, so the equal payment series fund factor, okay, so is the reciprocal of the uniform series compound amount factor, right? So we already saw the equal payment series compound factor, right? So I have explained that, and with that answer I have shown the derivation how we have got this, right? So now it is simply the reciprocation of this uniform series, or else you can call it as an equal payment series compound factor. Okay, so the formula here we are having is that uh, A is equal to F into I by 1 plus I power n minus 1. So or else you can simply say that A by F is equal to F by A into inverse 1, right? So that inverse, you can have the inverse. Okay, so as I now it is clear that this uniform series sinking fund factor, or else equivalent payment series sinking fund factor, is just the reciprocal of equivalent payment series compound amount, or else so-called, which is so-called uniform series compound amount factor, right? Okay, so here, it is given that in this type of investment mode, the objective is to find the equivalent amount A that should be deposited at the end of every interest period for n period, n interest period, to realize future sum F at the end of the nth period at an interest rate of I. Okay. So now we are going to find about the equivalent amount which we are supposed to deposit at the end of every period with some certain interest over it. Okay, so that we can have some future amount with reference to the for the period of nth year of end of the nth interest period with along with the interest rate. Okay, so again, that A by F ratio and I and N is called as a equal payment series sinking factor, or a fund factor, or else a uniform series sinking fund factor. Okay, so here A is your equal amount of the deposit at the end of each interest period. Okay, so already you're knowing what is En and what is I and what is F. Well, so now moving on to a problem that a company has to replace a present facility after 15 years at an outlay of rupees 5 lakhs. It plans to deposit an interest amount at the end of every year for the next 15 years at an interest rate of 18% compounded annually. Find the equivalent amount that must be deposited at the end of every year for the next 15 years. Okay, so here they have given you the, I mean, your period as 15 years, okay, with the outlay of 5 lakhs. So outlay of 5 lakhs is your future sum, okay. So, and also they have given you tenure of a 15 years and with the interest rate of 18. So 18 is your a compounded annually interest, which is your I, and they ask you to find the equal amount or a uniform amount for the same period of a time, which is 15 years of next 15 years. Okay, so each and every year you're wanting to get the amount that which you can equal amount which you can deposit till the 15 years of a period with the there will be the interest of 18 percentage to obtain the amount of the 5 lakhs of rupees. So now we can use the same formulas, that is A is equal to F into I divided by 1 plus I power n minus 1, and you can get the amount, and you can find the amount which you can deposit for the next 15 years, right? Okay. Moving on to the question posted in the question bank. Okay. So the question here is a person who is just 30 years old is planning for his retirement life, and he plans to invest an equal sum of 10,000 at every year for the next 30 years, starting from the end of next year. The bank gives 15 percentage interest and compounded annually. Find the maturity. Okay, find the maturity value of his account when he is 60 years old. Okay, so this one is a compound payment series, equal payment series, compound amount. This fifth question is all about. This is not equal payment series sinking fund, the fifth question. Okay, so let me check whether we are having this. Okay, so to to answer this question, they have given you the year that is okay, uh, you know 30 years of starting from the next year. So n is given as a 30 and the equal sum of 10,000. So equal sum, that is A, is given, and interest rate of 15% is given. Okay, that is A is given, N is given, I is given, and you need to find the future amount, right? And so you can use the formula F is equal to A into 1 plus I power n minus 1 divided by I, and you can substitute the values in the in the formula, and you can get the answer for the future sum of annual equal payments. Okay, so this is how you can solve it. Okay, this is the equal payment series compound amount. Okay, so you can check out the sixth question. A company is planning to expand its business after 5 years from now. The expected money required for the expansion program is 5 crores. The company can invest rupees 50 lakhs at the end of every year for the next 5 years. If the assured rate of return of investment is 18% for the company, check whether the accumulated sum in the account would be sufficient to meet the fund for the expansion program. If not, find the differences in amount for the company, which should make some other arrangements after 5 years. Okay, so mm, this is all about equal payment amount series present worth amount. So it is given that the company is planning to expand its business for for the next uh, 5 years from now. Okay, so again that the company having the investment of 50 lakhs at the end of every year for the next 5 years. And if the assured return amount is 18% of the company, check the amount. Okay, so this problem, before moving on to this problem, let's see about the equal payment series present worth amount and other factors, and then we will move on to this same question, and then I shall explain to you. Okay, fine. Then okay, so moving on to the equal payment series present worth amount. Okay, so to listen the equal payment series present worth amount. So it is all about the mode of investment is to find the present worth of an equal payment made at the end of every interest period for the particular interest period with the certain interest rate which is compounded at the end of every interest period. So here they have given UP is equal to A into 1 plus I power n minus 1 divided by I into 1 plus I into 1 plus I power n. Okay, so already you're knowing the terms for these. Okay, so just moving directly to the problem. So a company wants to set up a reserve which will help the company to have an annual equivalent amount of rupees 10 lakhs for the next 20 years towards its employees welfare measures. The The reserve is assumed to grow at the rate of 15% annually. The single payment that must be made now as a reverse amount. Okay, so in this problem, they have given you the annual equivalent amount that is of 10 lakhs rupees, which is for the next 20 years. So n is given, and it is assumed that it is having the rate of 15% annually. Okay, so now you are supposed to find the single payment that you can make it now, so that you can reserve the same money for the company use in the future. Okay, so for this, that they have given you the formula that you can use the same formula, that is a into 1 plus I power n minus 1 divided by I into 1 plus I power n. So for this, and you can substitute all the values and you can directly find the answers. The amount of reserve which must be set up now is equal to, you're getting the value of 62,000, 62 lakhs 59,300, which is verify the answer whether you're getting the same. Okay, and also along with this problem, you just take down, or you just go to the previous question which I have noted and asked you to complete it. I mean, sorry. Yeah, this problem. Hmm. So, again, coming to this problem, a company is planning to expand its business after 5 years from now. Okay, so you're having the value that n, I mean, period n is your 5 years. Okay, and and also it is given that uh, the amount expansion required amount is 50, I mean, sorry, 5 crores. Okay, so expected amount which is supposed to be having. Okay, so the company can invest 50 lakhs at the end of each year. So here you're having A is 50 lakhs. Okay, so you can use A as a 50 lakhs at the end of every year for the next 5 years. And assurance, the rate of return is given as 18%. So I is 18%. Okay. So what you can have is that use this for, I mean, the value substitute in the equal present series present birth amount, that is the formula which is already given. You just verify it and you can substitute in that. Okay, so if you're having the differences of amount, then you have to find the differences in amounts for which the company should make some other arrangement for 5 years. Okay, so you can find the differences in amount. The differences in amount is that the value which you are going to have, the amount which you are going to reserve the amount, right? So by investing it in 50 lakhs every year, okay? So with that amount which you will be having as the value of a principal, okay? So you just compare the amount with the 5 crores, the differences amount, okay? So that will be the differences in amount that you'll be having it, okay? So that is how you can solve the question number 6, okay? So I hope you are understanding this. Fine. We'll move on to the next. Okay. So next we're having equal payment series capital recovery amount. So the equal payment series capital recovery amount is also called as a equal payment or else a uniform series capital recovery factor. Okay, so equal payment plus series capital recovery amount is also the same, and the uniform series capital recovery factor is also the same. Okay, so to understand this, to understand the concept of this equal payment series capital recovery factor, so say for an example that an amount is a certain amount is deposited now at an annual interest rate of I. So we will withdraw the principal along with the interest in the series of equal annual amount, right? So the equal annual amount is in terms of A, right? So A. Okay, over the next several years. Okay, so so that you know in that worth, the principal worth is your. I hope you're knowing that P into 1 plus I power n, right? So for the end of that n years, right? So this amount will be recovered by receiving a, that is will be receiving with a equal amount A, that is equal amount, equal annual amount. Okay, so again to understand more clearly, you just let us consider with a different scenario involving some kind of a uniform annual payment or else equal payment annual series. So suppose that the given amount of money is P, which is deposited in a savings account where it earns some kind of an interest rate of the say for an example I I or else say for example 18% interest or something like that. Okay, so the I interest for per year, which is compounded annually. So at the end of each year, a fixed amount equal annual amount is withdrawn. So how large that would be means that amount of annual equivalent amount B, so that the bank could just be depleted at the end of n years. So You can use the previously mentioned factors, that is, you got this value, that A is equal to P into I into 1 plus I power n divided by 1 plus I power n minus 1. So actually this we got by including the factors of A is equal to P into A by F into F by P, right? So which we have already noted in the previous, that is your uniform series and so for compound amount factor and the uniform series sinking fund factor, right? So A by F and F by P. So this F by P already we saw in the single payment compound amount factors and all other things. So just verify that. And this A by P, I mean, sorry, A by F, we already saw in uniform series compound amount factor. Okay, so with that two equation substituting with this, that is A is equal to P into A by F into F by P, by substituting the equation of uniform series sinking fund factor and along with the principal single payment compound factor, that is F by P is equal to 1 plus I power n. Okay, and along with the yeah uh, I mean, which you can substitute all these two in the previous one, which is that A is equal to P into A by F into F by P, right? You can substitute these two. That is the which are the two. That is one is the sinking. I mean, that is the sinking fund factor. Yeah, that is A by F. P into A by F is your sinking fund factor. So, and then F by P is your single payment compound factor. So, right. So, by substituting all these, you will get this A. Okay. So, I think we are knowing the factor. This factor. Sorry. Uh, where's the sinking fund? Yeah, the sinking fund factor. This factor, and along with the P by F, this factor. That is your single payment compound factor. Okay, so with this, by substituting in this, that is A is equal to P into A by F, F by P, you can get the ratio for the capital recovery amount, right? So this is what this ratio is your uniform series capital recovery factor. Okay, so again you can use this formula to calculate your capital series recovery factor, or else you can use the a compound interest table to find the values. Okay, so coming to the problem, a bank gives a loan to a company to purchase an equipment worth rupees 10 lakh at an interest rate of 18% compounded annually. This amount should be repaid in 15 years, equal yearly equal installment. Find the installment amount that the company has to pay to the bank. Okay, so we need to find the A, that is the installment for a yearly payment, right? So they have given the purchase, that the principal amount they have given, that is your 10 lakhs with the interest of 18 percentage compounded annually. And also they have given 15 years, that's your period. Now you can use the formula and find the annual equivalent installment. Okay, so moving on the question bank. Okay, a financial institution introduces a plan for to pay a sum of 15 lakhs after 10 years at the rate of 18 percentage. 18 percentage compounded annually. Find the annual equivalent amount that a person should invest at the end of every year for the next 10 years to receive the 15 lakhs after 10 years from the installation. Hmm. Okay. So here, oh, they have given you the financial institution reduces to pay a sum of 15 lakhs. Okay. So total amount is 15 lakhs. The period is 10 years. Okay, and and the interest rate is 18 percentage compounded annually. So it is asked to find you the annual equivalent amount that a person should invest. Okay, so A, they have asked A. Okay, so you can use the same formula which is mentioned in the equal payment series capital recovery amount. So you can record the amount. So you can use this formula to find the annual equivalent amount for this problem. Okay, so that's what in this session, and in the next session we will see about uniform gradient series, annual equivalent factor, and effective interest rate. So you just try to work out all the examples and the tutorials which I have given you in this session. Okay. If you have any doubt or any clarifications, you can either mail me or else you can post your queries in the Google Classroom or else in the WhatsApp group. Okay. So I shall clear your doubt and then we can move on to some further relevant kind of problems as tutoring. Okay.